Right now, at this very moment, there are serious plans being drawn up to send humans to live on Mars. Billions of dollars are being invested, rockets are being tested, and volunteers are lining up for a one-way ticket to the Red Planet. But here's something that will blow your mind. We know less about our own ocean floor than we do about the surface of Mars. And here's an even crazier thought. What if living underwater on Earth is actually easier than living on Mars? What if we've been looking in the wrong direction this entire time? Today, we're going to settle this debate once and for all by comparing two of the most extreme environments humans could possibly inhabit. By the end of this exploration, you might question everything you thought you knew about the future of human civilization. Let's start with the basics. When we talk about living on Mars versus living underwater on Earth, we're essentially comparing two alien worlds. But one of these alien worlds is right here on our home planet, and the other is millions of kilometers away. That distance alone should tell you something important about the challenges we're facing. Mars has captured our imagination for centuries. The Red Planet, our celestial neighbor, has been the subject of countless science fiction novels, movies, and dreams of exploration. It's roughly half the size of Earth, with a day that's surprisingly similar to ours at about 24 hours and 37 minutes. But that's where the similarities end. Mars is a frozen desert with an average temperature of minus 63 degrees Celsius. Its atmosphere is about 1% as thick as Earth's and is mostly carbon dioxide. There's no magnetic field to protect you from radiation, and the soil contains toxic chemicals called perchlorates that would make growing food incredibly challenging. Now let's talk about Earth's oceans. Covering more than 70% of our planet's surface, the oceans represent the largest living space on Earth. The deeper you go, the more extreme the conditions become. At depths of just 10 meters, pressure increases significantly. At 1,000 meters, the pressure is about 100 times what we experience at sea level. It's pitch black down there, cold, and completely isolated from the surface world. Yet despite these extreme conditions, there's one absolutely crucial difference. There's life everywhere in our oceans. Abundant, diverse, thriving life. Let's dive into the engineering challenges of each environment, starting with the most fundamental question. How do you even get there? Getting to Mars is an extraordinary feat of engineering. You're looking at a journey of anywhere from 6 to 9 months, depending on the planetary alignment. You need to launch during specific windows when Earth and Mars are positioned favorably, which only happens about every 26 months. The spacecraft needs to carry enough fuel, food, water, and life support systems for the entire journey. You're dealing with the psychological challenges of living in a cramped space capsule with the same few people for months on end, with Earth becoming just another star in the sky. Then there's the landing. Mars has enough atmosphere to create heat during entry, but not enough to slow you down significantly with parachutes alone. Every Mars landing is what engineers call 7 minutes of terror, because that's how long the automated landing sequence takes, and there's nothing mission control can do to help because of the communication delay. The signal from Mars takes between 4 and 24 minutes to reach Earth, depending on where the planets are in their orbits. By the time you know there's a problem, it's already been over for minutes. Compare this to getting to the ocean floor. You climb into a submersible, you descend for a few hours at most, and you're there. If something goes wrong, you can abort and surface. You can communicate in real time with surface support teams. There's no launch window you need to wait for, no months-long journey, no interplanetary alignment required. The trip to even the deepest parts of our ocean, the Mariana Trench at nearly 11,000 meters, takes about 4 hours. That's less time than most people's workday. But arrival is just the beginning. Let's talk about actually building a habitat in these environments. On Mars, you're building on solid ground, which sounds like an advantage until you really think about what that ground is like. The Martian surface is covered in toxic dust that gets into everything. This dust is not like beach sand. It's incredibly fine, like talcum powder, and it's filled with those perchlorets we mentioned. It's also extremely abrasive and potentially harmful if inhaled. During dust storms, which can cover the entire planet and last for months, solar panels get covered, visibility drops to zero, and the amount of sunlight reaching the surface decreases dramatically. Your